developing software, it's really important that we test and debug our software before we distribute. It's really easy to have some errors that we might miss. One of the big topics today in the software industry is unit testing. And it's not part of our competencies for this course, but it's something that you need to be aware of, because if you go for a job interview as a developer, an entry-level programmer, there's very likely going to be a question about unit testing, what you know about unit testing. So there's all kinds of software testing that we can do. And what we've been doing so far is what I would say is an alpha test, in that as a developer, we're internally testing the function of our program and make sure it works. As we develop software, though, we might include external customers and external users and do what we call beta test or field test. So a beta test, usually we give it to the customer and we have them try it, or clients, users have them try it and report back to us the issues that they came across or suggestions. Field tests is where we'll usually give our software to somebody and we watch them use it. We don't really tell them anything about it, but we watch over their shoulder. Can they figure out how to use it, and does it work for them? Along with that, there's UI and UX tests, so looking at the user interface and the user experience. Are those sound? Could it be better? And sometimes that's just done with storyboards and getting feedback again from potential users. There's integration tests where we have multiple units working together, and that's very different from a unit test we'll talk about in a minute. There's regression tests that are done in that as we add new features, the question is, adding those new features, does the old still work? We're going backwards in time to make sure that everything is cohesive. Functional tests. Does the program do what it's supposed to do? Does that feature work as it's supposed to? But we're going to focus on unit tests. And unit tests are looking at individual methods really done inside of an object-oriented programming environment where we have a bunch of methods, and do those methods actually do what they're supposed to do? And we can set up unit tests that will test each method, and we might have, in a large project, 1,000 different methods, and we can test all of them very quickly by setting up a unit test for each one. That leads us into another topic that I'm not going to cover, but just you'll hear the term test-driven development, and it might seem a little backwards, but there we do the unit test before we actually develop the software. So why do unit testing? Well, it gives us confidence in our code, and it helps us find those errors very quickly, especially as we make changes to methods. We make a change to the method, run the unit test, and it really tells us whether the method still works or not. We can also test multiple scenarios. So we might have different forks with a conditional in our method, and we can write tests that test each one of those scenarios, whether an item is true or false. Or maybe in a switch statement, there might be a whole bunch of scenarios. Unit testing allows us to automate the testing, and so we can run hundreds, if not thousands, of tests in seconds or maybe a couple minutes at the most. And so it reduces our debugging time. As we're testing, like an alpha test, where we're just putting our program through the paces, we might forget to test a particular scenario. So by setting up a unit test, that helps to make sure that everything is covered. And it also provides documented verification that yes, these methods are working. So as I mentioned, each unit test focuses on one method. Now I need to warn you that unit testing won't necessarily catch every error. It does not replace the need to field test and debug our programs, nor does it replace the need for code reviews where we're sharing our code with others and getting feedback from other members of our team or other developers. And it certainly doesn't replace the need to comment our code and to provide documentation. With unit testing, we want to keep the tests simple, and we want to keep our methods simple as we build our classes. That's a big trend these days, to have each method focus on one task at a time. If our method handles multiple scenarios, we're going to write one test for each of those scenarios. We also want to make sure we name each test descriptively, because we're going to get a report. And if those tests are named according to the methods we're testing, that makes it that much easier. And we want to run these tests whenever we're changing our code. As we're changing various methods, we want to run the tests that cover those methods. And so we can run hundreds of tests in a matter of just a few seconds or a couple minutes. As I'm developing and adding more methods, I'm going to add more tests, and then I'm going to run all my tests together. So there's several popular tools out there for unit testing. In this video, I'm going to show you the MSTest, which is the Microsoft test. This is built into Visual Studio. It's been around since about 2015, built into Visual Studio. It's really the default testing method of doing things with C#. There's also NUnit, which I think now is built into 2022 Visual Studio, but prior to that was brought in as a NuGet package. Now, a lot of developers liked NUnit because there were some shortcomings with MSTest originally, and that was in terms of passing parameters. So in passing parameters, developers wanted to use testing that would accomplish that. They would bring in unit test. JUnit is really, I think NUnit I think is built on JUnit. JUnit is really used more in Java, but I believe now there are some ways to use that with C#. And another recent one is XUnit, which is also kind of based on NUnit. These all really work very similarly. With the MSTest, we would create 3 parts to the test, and we call this the AAA of testing. The first part's going to arrange. We're going to set up the scenario of what values we want to test. And then we're going to run that test. That's the act part. And if that test succeeds or fails, we're going to call an assert statement that generates the report. So arrange, act, and assert. Let's jump over to Visual Studio. In Visual Studio, I've created a WinForms project with one window, Form 1, that the user enters the length of side A and side B, clicks the Calculate button, and the project is going to calculate the hypotenuse, the area, the perimeter, and the degrees of the 2 angles, alpha and beta. If we look at the code, here's my Calculate button. It's going to call several methods: calculate hypotenuse, get area, get perimeter, get angle. It's going to call get angle twice. And those are located in a separate class called geometric methods that just contains the method, those 4 methods: calculate hypotenuse, get area, get perimeter, get angle. Notice these are all public. So when we're doing unit test, it's important that our methods be public, because otherwise, when we create the new project for the unit testing, it will not be able to access these methods. Notice that in my C# code, I created an instance of geometric methods. I called it GM, and that's what I used to access those different methods. Let me just run this very quickly. And so side A is 4, side B is 3. Click Calculate. Our hypotenuse, of course, is 5. The area is 6. 3 times 4 divided by 2 is 6. The perimeter, 4 plus 3 plus 5 is 12. And then we have our 2 angles of 36.87 and 53.13, which, of course, combined gives us 90 degrees. So our triangle is 180 degrees total. Now, typically, we would go through and we would try different values and make sure that everything is calculating correctly. Let's see how we can do this with unit test. Now, there are a couple ways to add the test project to our solution. So I have my WinForm project. I could come to the solution and right-click and choose Add New Project. And then I could say I want to add a test project. You see there's different tests here. We talked about the MSTest and the NUnit test. Notice that on these are referencing the .NET Core, and what I'm using here is the .NET Framework. So I want this test of unit test project, and I could choose that and then click Next, and I can create a project. It would add a project here in the solution. I'm not going to do that. I'm going to cancel that. I'm going to show you an easier way to do this, because if we created that project, we then have to create some dependencies between that unit test project and our WinForm project. Instead, what I'm going to do is I want to test these methods that are in the geometric methods.cs class. So I'm just going to go to calculate hypotenuse method. I'm going to right click and I'm going to choose create unit test. So this is going to create a new test project. It's going to use the project name and test after that, as well as the namespace.test. Now, if you want to change those, you could. I can name this something else. Let's call it geometric test. I'll just click OK. and has now added a new project to my solution named geometric test, and I get a class called geometric methods test.cs. In my geometric method test, I am going to add a reference to that geometric methods class. Again, let's call it GM. And then I have a test that's been pre-created for us called calculate hypotenuse test. It took the name of the method and added test. Now I'm going to create one test using integers and another test using double values. So I'm just going to say this is whole, test whole, or I could say test integer. Now I have an assert fail here. I'm actually going to do away with that for now. And remember, we said that we used arrange, act, and assert as our 3 steps in creating a test. So for arrange, I'm going to create a variable. Now it's expecting double values for that calculate hypotenuse method. So I'm going to say double A equals 4.0, which was the value that I used earlier when I ran the program. And then I'm going to create another value called expected. And we're going to say it's 5.0. Now, just remind you that for the geometric method, it's taking 2 doubles and returning a double. So that's why you made those all doubles. So that's setting up my test. That's the arranging of it. Now let's act. It's going to return a double value. So I'm going to say double. Notice that it gives me the IntelliSense here of actual equals GM calculated hypotenuse A and B. That's exactly what I want. I'm just going to say, press tab key. That's going to test it. Now we need to assert. So I'm going to type assert dot, and there's a whole bunch of methods for asserting. I'm going to use R equal. And what I want to check to see is, are the expected value and the actual value, are those equal? So again, I can just use the IntelliSense and just press tab twice, and there's my test. And I see I misspelled geometric methods up here. See a little squiggly, let's fix that. And that's my first test. I can create a whole bunch of tests. Well, let's just run this. So I can go to the test menu and choose run all test. Dialog pops up. And I get some information here that 1 test passed and 0 failed. Let's look at the past test. There's my geometric test. Just kind of continue to come down here. And I can see that on this test, it succeeded. I get a green check mark. And I'm told how long it took, 52 milliseconds. Let's come back to our test. Let's say I expected 5.5. I'm going to run the test again. And now I'm told 0 passed, 1 failed. And we can see the test that failed was the calculate hypotenuse test whole. And we're told that we expected 5.5, but we actually got was 5.0. Let me set up some more tests. So I added some more tests. One called calculate hypotenuse test double, in which I'm giving it some floating values and what I'm expecting from that. And again, just running the test, same thing, looking at R equal. Here I did expected in C. Could have used actual, as we did above. Then I did another test for the angle. This is going to be for the alpha. And it should come out at 36.87. And for the beta, 53.13. Now, if you look closely, I ran this prior as well. You see a little red X here, and one here, and one here. And then up here we have a green check mark. So when I ran this, after I typed these in, these three failed. Let me just demonstrate that, and we'll talk about why they failed. So I'm going to go to the test, run all tests, and notice I get 1 passed and 3 failed. So let's look at our geometric test. The test that passed was the one we had earlier, test whole, but 3 of them failed. And let's take a look at the calculate hypotenuse test double and see why it failed. So I was expecting 15.9. What I got was 15.9 and a whole bunch of other decimal values because the 15.9 is rounded. So they don't equal each other. The same thing happened on the angle alpha, 36.87, 36.86989, and then the angle beta, 53.13, and I got 53.1301. So my test is faulty because of the double value that's being returned being calculated out to a much larger representation of decimals. Well, how do we fix that? Well, I can add math.round, and so I'm going to take that value that's calculated from the hypotenuse, let's round it to 2 decimals, which is what I'm expecting, 15.90. And we'll see if that comes out accurate. I'm going to do the same thing down here. What I'm going to do is just copy that, paste, comma 2, and on my get angle beta test, we'll do the same thing. So now I'm going to run the test again. This time I get 0 failures and 4 successes. And all 4 of my tests were successful. If I were to change one of the methods, let's come back in here to my geometric methods. Let's say I'm making some changes to one of the methods. And maybe I just get a formula wrong in here. Let's say I make this 120. I'm going to come back. I've just made that change. Let me run my test again. And now I get 2 failures. So my 2 angle tests failed because my calculation I had mistyped in the geometric test. So this is how you can create tests and continue to code, and as you make changes, just test to make sure everything is working correctly. We go back to 180, run my test again, and now I'm getting 4 successful tests. Then I'm going to go back and do a test for the get area and get perimeter as well, make sure those are calculating correctly. So you could have a lot of tests being generated as you develop your code. It's probably a great idea to do a test for every method that you have. Just remember the methods have to be public. The class that they're coming from also needs to be public. If you just jumped into this video, you can see all the videos from the C# Xamarin Programming Cohort playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.